Good morning, students. Hope you all are doing well. Welcome to all of you in lecture number 4. And in lecture number 4, we will cover window techniques and raise model. If the time permits, then I will cover raise model. So first, we will discuss about the window techniques, right? So first, I will draw the windows, then explain one by one. So in last class, one thing I was explaining is very important is attenuations. And attenuation due to the intrinsic properties, right? Due to the silica itself. So first, windows. So windows, if you able to see and observe in your bedroom, some windows is already there. So please see, window is not a one dot. Windows has always one width, right? So windows have some width. So there be some look like this. Second is here. Intentionally I have put it and drawn this decreasing order. I will tell or explain in later page. Right? Now this is the wavelength. Window is based on wavelength. First window lies between 800 to 850 nanometer, right? Or somewhere also write you can see, so don't confuse 850 to 950, both can be considered. Second windows is considered from 1250 nanometer to 1350 nanometer, right? So and third window, first window, this is the first window, this is the second window, and this third window. Third window is nothing but 1550 to 1650 nanometer, right? This is the wavelength. So why the first question in your mind, why is sir has intentionally drawn this first window is higher attenuation. This is the attenuations. Y-axis is attenuation graph, and attenuation is always, I already told, in dB, p by 10 dB, p by 100, right? And p by 1000 and p by 10,000, like that. So this is the third window, right? And see, in the third window attenuation is decreases. Why? So that means attenuation is a factor with the wavelength. If the wavelength is increases, your attenuation will decreases. So in the first case, when this window is supported by in 1970s, this is near about 1990s, and this is near about 2000. Windows has proposed by ITUT, International Telecommunication Union, and all the standardization is optical relations, optical fiber communications is standardized with the G. So when you will see ITUT G something, understood this is the optical communication standardizations. Since as far as the wireless communication, if IEEE was the main organizations, then 802.11b, 802.16d, 16e, or many one, right? 15.4. So that is the for wireless part. For wired communication, optical fiber communication, always standardization will be start from ITUT and G something, right? So here this is the 1970, this is the 1990 and 2000. This window has been developed. Why this window has been developed? Because due to the intrinsic properties, initially scientists was found the impurity is very high, so attenuation will be very high, right? So attenuation is very high, right? So near about this is near about 0.2 dB per kilometer. This attenuation has calculated on the basis of dB per kilometer, right? So second one here, and third one is, so this one near about 10 dB per kilometer. This one is 4 dB per kilometer, right? So as the progress happened, second window will look like this. Third window is look like this. In all window, you are able to see there is a intentionally peak is appeared. Peak is appeared, right? No doubt. This attenuation 10 dB, attenuation 4 dB, attenuation 0.2 dB kilometer is the power factor reductions, right? And this reductions due to silica impurities. Silica impurity, that is known as which property? Intrinsic property. Due to the silica intrinsic property, this attenuation is appeared in different windows, right? So, but at the same time, you are also observed there is a peak in first window, in second window, in third window. Every window there is a one peak appear just after the window, right? Near about the window. Why this will happen? Why this is appeared? So in last class, I was explaining some basic concept about the OH minus ions. OH minus ions. So OH minus ions is nothing but the absorptions of the water molecule. Due to water molecule, this absorption has been happened. That's why this peak has been appeared in all windows. Right. So first question is, how many windows in optical fiber communication system? There are 3 windows. First window, second window, third window. 9070, 90 and 2000. This window has been developed by ITOT. And this window, increasing the window, your attenuation will be decreases. So the question is, so why not we are looking for the 4th window or 5th window? Yes, you can. But currently, as per standardization, we are using 0.2 dB per kilometer. Is the per kilometer. The optical fiber length is 1 kilometer. By default, 0.2 dB loss has been appeared in the optical fiber. So the question is, why as wavelength increases, this value is decreases? No, not only the wavelength, right? Yes, wavelength is one factor. If you will work in this 1515 nanometer windows, yes, very good. Attenuation is less. But what is the factor is associated with the other factor? Other factor is associated with this, so that the reduction attenuation. So other factor rather than the wavelength is known as materials, right? Compositions. Material compositions is nothing but we will use gallium arsenide is the first material to optimize this attenuations, right? So why gallium arsenide? So because gallium arsenide is nothing but the direct band gap material, right? Direct band gap materials, right? Same in the case of second one, gallium, aluminum, arsenide can be there, right? So different. We can able to understood that gallium, aluminum, arsenide, these direct band gap composition, this direct band gap materials can be able to reduce this attenuations. How to see? So there are 2 types of materials. One is the indirect band gap, and other one is the direct band gap. So direct band gap, what are the factors associated with the direct band gap? So see here. So I will explain the concept. This is really good concept, and any interview or for your future perspective, see the basic difference between direct and indirect band gap. So let us assume that See the concept. Now I will use other pen for this recommendations so that you can able to understand. So this is the conduction band, so EC. This is the valence band for EV. So electron, very good. Electron, 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 electron. Now here is the holes. Holes, very good. Holes, very good. Now again, electron. Now again, holes, very good. Holes. This is again conduction band. This is again valence band. This is again now see. Now observe the one factor scenario. If you want to handshake with your friend, if he is in front of you, then directly handshake. But you are here and your friend is here. So now you move here and then do the handshake. So to move from this position to this position, you lose some amount of energy, right? If your friend is directly, okay, hello, how are you? But if your friend is there, then you move and then hello, how are you? The same things here. You are able to see here. This and this portions is directly aligned, right? So this electron is directly recombined with this and produce the energy, right? Let us assume that this energy Eg. What is the condition? This condition is directly when your friend will handshake with direct in front of you. Hello, how are you? So no energy waste, directly recombination. Very good, fantastic. I am good. Now in the second phase, when electron is here and they were here, if you will try to handshake here, there is no man, there is no person. Your friend is not here. Your friend is here. So to recombine this, you should release the some amount of energy. Release the energy, and then you want able to handshake with your friend. Now here, since electron is not able to align with this holes, so you should release the energy. Right? Energy. And due to release the energy, momentum shift, right? Momentum shift. So due to momentum shift, since here, this is the y-axis is the energy, y-axis is the energy, here also energy, y-axis is the energy, and axis is the momentum. So here, in this case, if you want to handshake with your friends, you should shift, momentum shift, and to travel some distance, you should release the energy, right? And then recombine. Then energy is Eg dash, right? So, what is the concept between direct and indirect gap? Without I explain further, you understood. If there is a direct recombinations, there is no energy moment, there is no change in momentum. Direct recombinations is known as direct band gap. Right? Now, since here, first momentum shift, then during this momentum shift, energy, release the energy, so some amount of energy is waste. Now these recombine, Eg dash. So the question is, which one is better? Which system has the better gap, they will release the better energy, high amount of energy. So simply, I think no one have any doubt. Through this relation, we can see Eg is greater than Eg dash. So why this alloy? This is the combination of alloy, indirect band gap, silica different, silicon, gallium alag, different. So alloy combinations. In alloy combinations, what is the difference? release the momentum shift, right? Release the energy. So energy gap in the direct band gap is greater than Eg dash, and we know that energy combination of energy is known as photons, right? So in combination of energy is converted into packets, and packets of energy is known as photon. So due to these recombinations, packets of energy recombination, they will able to generate the photon, but this energy will be lesser amount, so chances of to release the photon is lesser. So finally, I think you are able to understood the concept of direct band gap and indirect band gap. So here you are able to see you are using gallium arsenide, gallium aluminum arsenide, here gallium aluminum arsenide phosphide, right? And one thing is very important, if someone doing the research, someone wants to do the research, in which compositions, let us assume that gallium part is 1, arsenide part is 1 minus X. So yes, many researchers are doing in such a way, which is the combinations required in gallium aluminum arsenide, how many parts of this, how many parts of this, how many parts of this, so that the attenuation can be minimized and the support of the data rate is higher. But attenuation is lower, no doubt power is higher. Power is higher if the power of the signal is higher, then signal SNR will be higher, then capacity will be higher, then data rate support is higher, right? So this is the real requirement of any system. So in this lecture I have explained first the window techniques. Window, that means different bandwidth. So 800 to 850. Sometimes, if you want to take the average value, so just remember 850 to 950. No doubt, right? No doubt, please. Well, you will remember only these things. 850 to 950. This is 1250 to 1350. Third one is 1500 to 1600. Best one is this. Best one is this. No doubt, because the higher the wavelength, lower the attenuations, and it also supports by gallium aluminum arsenide phosphide, and that is the latest window, and that will released in 2010 to 2010 between, right? So this is the basic concept related with this window techniques. One concept is very important. Why this peak is appeared, this third window? So why this peaks appeared? Due to hydroxyl ion observations of OH minus ions. What is the basic difference between direct band gap and indirect band gap? In indirect band gap, momentum shift. Due to the momentum shift, release the energy, right? Due to the energy release, they will waste some amount of energy and then recombine. That's why Eg dash is lower than the direct band gap. So if anyone could you please tell me some the compositions of direct band? You can tell gallium arsenide, aluminum arsenide, gallium aluminum arsenide phosphide with the different combinations, so that direct band gap can be happen. So direct band gap happen. So Eg plus Eg dash, Eg plus Eg1 plus Eg2 plus Eg3. That means the combination of energy, right? So combination of energy known as packet. If the packet energy is known as photon, so photon will release, then that means the communication will be appeared, right? So this is the entire concept with the today class related with the window techniques. So hopefully from first lecture to fourth lecture you are able to understood the basic concept of the optical fiber communications. This is the first and this concept is also known as journey of optical fiber communication. Journey of optical fiber communication, because this has started from 1970 to 2010. So 2010, right? Now hopefully you understood this concept. Now we will move today's second concept, and that is known as rays model, right? So we will see the rays model. So the first question being asked is, if I want to ask to you peoples, light has dual nature. You peoples, I think understood the light has dual nature. One is a particle, another is a wave, right? So first in castatics, so rays model. rays model. Right. So today's second agenda is rays model. Rays have the two nature. One is a wave, and second one is the particle. Right. Right. And if the nature is associated with the wave and particle, so it is also associated with the scalar and vector nature, right? So wave nature is maybe a scalar or vector nature. So how, as a simple, I can want to ask you peoples how you can tell this scalar nature or vector nature associated with the light, right? So out of 60 students or 70 students, you can tell about something about the scalar and vector. So if you deal with only the magnitude, right, and if you deal with both the things, that magnitude and directions, then you can explain with the vector nature. Now I will explain this concept, the rays model, with the real-time examples, right? So real-time examples with the practical scenario, so that you can able to understood in a better way to memorize the concept for the better understanding. Now first is let us assume that first concept is scalar, right? Scalar. So first concept is related with the ray. If anyone can tell about the rays model, and rays model associated with the scalar nature, the first thing is intensity. Intensity. How we can define the intensity? Intensity, right? Second one is first one, the intensity. Intensity is really important. Third one is second one is the wavelength. I will explain one by one. Wavelength. Right. First one is the intensity. Scalar quantity has the first one is the intensity, then wavelength, and third one is very important, the spectral width. Spectral width. Right. So scalar nature of the rays model can be defined by intensity. Second one is the wavelength, and third one is the spectral width. Right. So see, intensity. How we can define the intensity? So I will explain these three concepts with some branded clothes, right? Now let us assume that if you will purchase one T-shirt in good quality, branded showroom, and in the front of showroom the same types of T-shirt is selling by some shopkeeper on the some normal shop, but you can find out they are looking same, but when you will minutely observe, all these three quantities are different, right? Why? Because when you will observe the real time original branded shop T-shirt, the intensity will look like different. And why intensity look like different? Because that is all the colors combination, everything has done by R&D, right? And a lot of research group has been associated with that one. But as a normal, they are directly made the T-shirt and sell and sent for the selling, right? Now how we can define the intensity? Anyone? How we can define the intensity? So power distributed by per unit solid angle, right? So intensity is nothing but if solid power distributions, power per unit solid angle. How the power is distributed per unit solid angle is defined by the intensity, right? So in the rays model, how we can define the intensity? Power distributed per unit solid angle, right? So this is the real time of real definitions to define the intensity. And intensity of the t-shirt in such a way, or reflected of the light on your t-shirt in such a way that is not, so pleasant. They should be pleasant, not look like, very deep color, or very very high intensity color, look like pleasant. So that will be defined by the distribution of power per unit solid angle. And if this is good, so that material should be very looking by or for producing by is very useful. Second one is the wavelength. Wavelength is nothing but the color spectra. Nothing but color spectra. Right? It is nothing but the wavelength is you can just review. You can see the split is you have done in 9th or 10th class experiment and you can see the color spectra. Through color spectra you can able to see the wavelength of red, wavelength of blue, wavelength of green, you can able to see, right? So wavelength anyone can define. How can? So color spectra will define the wavelength. Third one is the spectral width. This is really important, because I already told in rays model color spectra is very important with the spectral width, because a laser and LED I already told why a laser is good one, because due to the spectral width. And how we can define the rays model spectral width? It is nothing but the purity of color. So this is really three definition is very very important. Intensity defined by power per unit solid angle, power distributed per unit solid angle. Wavelength defined by color spectra, and spectral width nothing but the purity of color, right? This is really R&D part. Because I already told and given one example. If you want to purchase the same look like t-shirt from two different sections, one is the branded, one is the normal, you can able to verify, you can able to differentiate this purity of color. Purity color is really pleasant, so that this scalar properties can be defined. So now the first property is scalar properties, and the scalar properties can be defined by intensity, wavelength, and spectral width. Second property is the vector quantity. So we already know vector quantities depends on magnitude and directions. And can you tell anyone which one the main factor for the vector definition? Vector relation with the rays model. So nothing but it's really easy, and I think in every year GATE examinations ask one questions related to either from the EMT or from the optical, and that is related with the polarizations. So polarizations concept is directly related with the vector properties with the rays model, and this property is nothing but the one is the linear polarizations, second one is the elliptical polarizations, and third one is the circular polarizations, right? So linear polarization nothing but very easy, right? If the both magnitude, both magnitude A vector and B vector both are equal to, but the separation of 180 degree. Here I will explain in detail, because this vector quantity is really important. Polarization is very important. Here A not equal to B, but angle is 90 degree. But here in circular polarizations, A is equal to B and angle is 90 degree, right? So circular and elliptical, if I want to show the practically, so let us assume that my two hands is here, and if the angle both are 90 degree and both are same, so the resultant of this, how resultant with this? So see here and 90 degree, so resultant is here, again here perpendicular, again here, so move like this, right? So circular polarizations is nothing but if magnitude of my hand, though both hands same 90 degree, if I will reduce my length of the B, but angle is again same, that is known as your elliptical polarizations. And this is the conditions. This is the linear polarizations, A by B is equal to 1, right, and angle is 180 degree, right. So this is the all three conditions is associated with the vector properties is associated with the rays model. So rays model again I will explain. Rays model is a really important factor to how to characterize the rays for the optical communication system, how the rays will be propagated inside the core of the optical fiber. So there are there are two very important properties, scalar and vector. Scalar have the three properties: intensity, wavelength, and spectra. Intensity is nothing but the power distributed per unit solid angle. Wavelength is nothing but the color spectra. You people already read in your 8th or 9th class. And spectral width is totally depends on purity of color, right? And at the same time, vector is directly related with the polarizations. And in the here we can explain the linear polarizations, elliptical polarizations, circular polarizations. I have already given the example also by my two hands, and you are able to understood these three type of polarizations. So hopefully, friends or my dear students, you are able to understood the basic concept of the window techniques and rays model, basic rays model. Basically, sorry, due to the time limit, I will explain the rays model in real time scenario with the some experiment. We will use the flashlight of the mobile, and then you can able to understood. Yes, sir, we are able to understood this scalar and vector concept. So till then, thank you to attend this lecture number 4. All the best. Thank you.